Hello, hello. How's it going, everybody? How's it going? We are doing, what is with this? My window was off kilter. We are continuing to play around with Tauri commands, but like that feels simplistic to say. At the surface, a Tauri command is a DX focused way to communicate from the web view to the Rust side of things. And it works well for like simple interactions. And there is sort of like an intermediate level where you start getting into async, and it's async in the Rust side of things, which is a little bit non-obvious relative to async in the web view, because the web view is always going to be an async because it's an invoke. But then there's like another level sort of like past that where you get into async, but then you want to have control over that asynchronicity. And that's going to be kind of what we want to dig into today. And one of the ways you can do that is with channels, which is still, I wouldn't quite say it's like expert, and it's probably getting more into the advanced. But it's a way to give you a little bit more customization without having to go like full control, and you need to understand all the like internal bits. So we'll probably play around with channels. I don't know of a good example of that. So we're likely going to take the existing command example and probably spin up some options with channels inside of that example. We're gonna spin it up in the Tauri playground though that we've started, and then it might make sense from there to actually like pull it out and pull it into Tauri Upstream. But we're gonna make a start first. Ooh, typing over here. All right. We're gonna start it first in the Tauri playground, which if you have not stopped by the stream, or you're new to the stream rather, Tauri playground is a repo that we've been over time committing to, which any like play testing stuff out, non-production ish type experiments, those end up just landing here as a place to share, but not necessarily as like a place where there's any expectation for like production level quality, if that makes sense. We're basically like the thing we figured out on stream, we just push it up there and kind of don't think about it deeper. So that being said, let's go. I'm not sure why this signed me out. But I am not in the mood to play ground. Not in the mood to deal with that at the moment. So this is we can drop it in the chat here. This is the Tauri Playground repo. I think we'll end up just spinning up a new option in here. You can see we've got a few things in here. Our like, I think this is our first official like, what does local first look like in Tauri? Then we have a few other things like multi-web views and Tauri GUI. Windows vibing is playing around with the Windows vibrancy crate, I believe. And this is the most recent one. I mean, you can see some of these we just, like I said, we tossed them up here and we haven't touched them in a bit, which is fine. The most recent one though was the deep links, and that was we streamed that a couple months ago, and I actually pushed it up real quick, which sometimes I forget. Okay, so what we're gonna do first is we're going to from here do a create Tauri app, and I want to just double check and confirm that I've got the latest. We'll do cargo. Yeah, sure, why not? And we'll create a new app, and then I'm gonna copy and paste bits from the command example. Tauri, yep. So within here, there is an examples repo and commands. So this will be sort of our starting off point. We'll call it advanced async commands. Sure, that feels fine. We are going to do it with TypeScript and JavaScript. NPM is fine. I guess we just go with vanilla. And sure, TypeScript, why not? All right. So now we have our new project. I'm going to restart extensions because that always bugs me. Thanks, Dream Elements. I feel like it's so inconsistent. Like maybe once a quarter I see a message from it. I don't know. Anyways, I just restarted you. Do your thing. Okay, so we have, like most Tauri projects you'll see, we don't need the VS Code. We can delete that. We have a source and a source Tauri. Source Tauri has the bulk of our Rust. We are on version 2 here, stable, and in our source we have a main.t disconnected. Interesting. Seems there was a blip in the internet. It seems to have recovered. Okay. So this is pretty straightforward. I think we'll go ahead and start copying stuff into here. We have an async function, and that function is firing off in Invoke. And we are attaching to that submit button. If we look in here, this has a list of commands. We're not going to grab all of them. At the very least, I want to hit on all the more advanced options. This commands.rs is a quote simple example. The only reason it's separate from main.rs is to show how it works. We saw that note the last time we were playing around with it. So in reality, we are probably looking at we'll probably start with some more of these async options. So like here we have raw feature commands and commands using window. Okay. So within the, we had started touching on this too. The options to your function We've got a few. There's the window. There's arguments, and then state. Is there like a combined option? So all of these just take an argument. That would be passed from the, it's like the payload effectively, which would come from the web view. See a lot of the argument. Here, this one has state. I'm just curious if we've got a combination of. This one is non-indent command function arguments. I'm not sure why it says non-indent, or like what non-indent means. This one specifies a struct and uses that struct to basically give that payload structure. I don't know if the TypeScript comes through on that or not. I don't think it does unless you're using something else to help you out with that. Borrow command, and then all of our wiring. So I think the first thing that we're going to do is I want to grab this window label because I want to see if we can do a combined one. We're gonna kind of just jump into the more advanced options right away. Yes. Hi. Kitty needs her nails cut. Come on up. Ow. It hurts. Ugh. She has her claws. Usually it's not a problem, but when they get longer, at least she's got a little bit harder time controlling what's pokey or not. So what is normally not pokey ends up becoming painful. Kitty, want to say hi? You're kind of talkative today. Say hi. No? Camera shy today. Good to see you, Rudrush. I always goof it up, don't I? Rudrush. Okay, so we have a I don't know if you can hear that coming through the mic, but she's like rubbing her face all over the desk. Hey, over here. Are you just fine doing that? Yeah. Okay. Anyways, I don't really care about the shell plugin. Oh no, now you're gonna say it. Oh, never mind. Faked me out. I don't really care about the plugin shell, so I'm just gonna remove that. The greet command is the first command that we've got. Oh, I used a cut. Are you gonna say hi now? Just needs attention. All right, so we have a window here. I wanted to see if we can get. Let's see. So this is an async simple command. This has an option. So like functionally, how are they different? It would be nice to like be able to see these side by side. I mean, other than like doing this. Whoop. I don't think we have too much. That is Okay, so if we have a check for snake command, or for what is it, snake, which, where is that? Here, rename all snake case. So depending on how they've named it, it uses the snake case. We've got a few with state. I don't see anything specific in the web view though for those. Response optional. We've got some invokes. Okay. So we don't do anything specific for the state options either. And run command is name, args, and false. Okay. Black shirt and cat hair do not. Well, they mix, but in an unfortunate way. Okay. You know what? I think I just realized if you're doing an async function, you need to pass the argument as an option. That makes sense. So in this case, we're calling it an async command, and we are returning a raw future. And that in that case, we have to do the standard future ready and pass the argument. Oh, this is specifically with a return. Same here. I don't see a strong reason to. I mean, like, I suspect there's a reason to do this. I don't see the reason to do this for our demo. I would presume the reason to do this would be if you want to have more direct control over the like interaction with the future. So I think we're just going to start with async command, and I don't really care about renames. So let's go here, and if we not getting any like hovering or anything, arg is, we'll say a option string, and I think that's probably all we care about, right? Oh, capitalized string. And then command async. So this is going to print window label. And then we'll also do arg. And it is, yeah, I just noticed Rust Analyzer is not running. Let's go ahead and open up VS Code directly in this advanced async commands. That should help us out then with Rust Analyzer. One of the signals that it uses is the we gotta open up the root one. Like what's in the folder. And if we look at, in this case, our Tauri Playground, we don't have anything in the folder that like indicates that this is a Rust project. I think that like extra level of nesting, it doesn't, like Rust Analyzer doesn't walk the tree. So it seems like it goes in the current level and one level deep. Which happens to catch src Tauri if we open VS Code up in the root of this like nested project folder. Okay. Anyways, if we open up now again this, now we're getting some help. Here we go. So string option, we need to do arg unwrap. That will potentially panic, but that's fine. We are not protecting this against production bugs at the moment. We're kind of just testing out what the APIs look like. All right, so when we look at this, we are doing an input element greet message element, and we're adding an event listener. We also need the index. I'm gonna take out, I don't really care about the assets here. Style sheet, we probably want a style sheet. We'll say advanced async commands. And then this row can go away because we don't care about the logos. And we have a form. So our form is going to be an input, which in this case, we're filling in input with greet input. And then you can click the button. I don't really care about the form. So I'm just going to get rid of all of this. And if we need any more, we can wire up somewhere. I gotta move this over a little bit. All right. I'm like twisting my hand a little bit here, weird. So now this will give us an input. I think I actually want to switch this though to a select, because we don't want to like a pure input. I think I just want to give a bunch of options for you to select an option, and then no, actually, we'll do it separate. Select, and then do we have can I quick fill in emmet, show emmet commands? Nope. Okay. I haven't written a ton of vanilla JS lately, so I'm gonna have to look it up. Sure. We can get rid of this. So that should give us one option. Element has no title attribute. Name, ID. Okay, well, I'm not worried about that at the moment. And then we're gonna call this a arg input. Enter in arg value. And then submit. Fire command. I don't think the name matters too much, but command selector, sure. It only matters insofar as how we use it here. So in this case, we're doing a prevent default. I don't know that matters at this point, but it's specifically listening or adding a listener to the submit button. But we can say go away here. We are going to add an ID to this. So we can just select the button and add a click listener directly to it. We don't want type we don't want type submit, because then we have to have the prevent default. And ID would be because if you have type submit, then it presumes it's a form. So I'm pretty sure that would try to do the like default rerouting form handling that happens with the browser. Fire command, sure. And the ID is fire command, and we're going to add an event listener. Click. We want to click listener. So now that should fire off greet. And we will do console.log fired. Now, some of this isn't going to quite work anymore because we renamed this. Greet message doesn't exist anymore, but we still have an arg input, and we have an, I'm going to rename this arg input element and command select element. This is an HTML select element. And let's just do that with it for the moment. And go ahead and do an npm install. Yeah, it doesn't do it. And then we'll have to run it. npm run Tauri dev. Okay. So what that's going to do is it's going to build everything. We should, I believe, it's not clear to me like what command, like does the ordering of these commands matter or what? We'll have to deal with that. And I guess we're gonna have to deal with permissions as well. We deleted shell. It does not like the fact that we are asking for permissions because we don't have the plugin, which makes sense. The shell plugin, I'm not sure why it comes in as a default, honestly. The shell plugin is for logging out to the terminal, which is useful, but okay, not found in this scope. Cannot find type window in this scope. That makes sense. We need to, just coming from Tauri, right? Yep. We're gonna have to fix some of these too. We are calling function greet, and invoke greet, and here we're calling this. So let's do we'll just generically call it fire off command. There. And now on this end, it'll be whatever invoke we do. So we can get rid of this one, because in this case, we're going to invoke the window label. And we need to add it to the handler. Okay. Unused, that's fine. Okay. That should build. All right. So now we can choose an option, and then we enter in an arg value, bloop fire. Now we should see in the console fired. All right. Why does OBS keep disconnecting? That is very odd. I do not like that. Let us check something out real quick here. It doesn't seem like a network issue. curious. That is interesting for sure. It is like disconnecting and reconnecting to the network though, which is odd. That is very odd. Computers, folks. Computers. All right. Well, hopefully it's not terribly disruptive. We have a select. Can we give that just a smidge of style here? Where is our CSS style? CSS. We don't have any logos. I'm just gonna get rid of that. Root. Colors. We got a container, a padding top on the container. Don't think we need any logos. Here we're gonna do we've got a row. Sure. We'll say div and class equals row. That is not what I was expecting. Oh, it fluxes in the other direction. Okay, that's not actually what I want. We're gonna get rid of that just so I don't use it again. I'm gonna leave the div in there. That's probably fine. There we go. I guess I'm gonna take the div out. We have button stuff, greet input. I'm not going to style the thing directly. Here we've got some styles on the inputs. We have a select, an input, and a button. I'm gonna do we have an input and a button. Guess probably a select, an input, and a button. And then, so that's a padding within. I'm gonna just do a bit of margin. And we'll do 0.5. There. That should be sufficient. Okay, now we need a couple more options in here. Yeah, well, we'll put that over here for right now, and then we need a window label. So we'll say with an arg with window label, and that'll be a window label. So now in our main.ts, we should be able to get the content. So this will be our input value, except it's an arg. And then we need a, I think that's a dot value. Yeah, it looks like it. Arg is possibly null, that's fine. So now, refresh. Oop. Got an extra option in there. Oh, what is struggling here? Now, hello. Sure. Okay. We interesting. So arg input is going to be and this is going to be command selector. Command selector. So now, hello. Yeah, okay, that makes sense. So now, I didn't think it was a value. Command select dot value. Command select. It is sets or retrieves the value which is returned to the server when the form control is submitted. So why is that throwing in an error? Can I read properties of null? Reading value. Is it specifically because it was not defined? I'm going to put that right up in the corner there, and then we'll say hello. There, hello undefined. It's not dot value, is it? And we closed MDN. So let's grab that again. Each option should have a value. You can include a selected attribute on an option to make it selected by default when it first loads. Value property which contains the value of the select option. It does not appear to be the case. Let's just log out the whole command select. We might be ID command selector. That's it. Our query selector was not correct. Okay. There we go. And then this again needs to be a dot value. Oh, not that value. Okay. Now, now we can do our invoke. And well, we could do this invoke directly here. I'm tempted to say real quick, let's take a look at Tauri Specta. This support for generating types for events. So this handles doing the events. Here, type safe Tauri commands. I'm curious how much of this is all wired up to. Yeah, I'm curious how much of this is all wired up. So we need to it says it's not. Okay, so there hasn't been an actual updated release, it doesn't look like. Okay. So they've unlocked. We can let's see, TypeScript. All right, we're using TypeScript, so I think we want TypeScript. We need to do a cargo add. So we got to do cargo adds Tauri Specta. We got to do it in the source Tauri directory, cargo add Tauri Specta. We need to then add Tauri Specta and that. It also says that this is always required. I don't think we don't need to do the add Tauri though. So we're gonna go like this. And let's take a look at our cargo.toml now. So we have a Tauri Specta with a specific version and specific features, and a Specta. Let's double check. They had mentioned in the release that they've unlocked the Tauri version. Okay, so it's not specifically tied to a version of Tauri in theory. In reality, it is, but they've unlocked it to where it might still work fine. So we'll have to see. Now, we did do this with the expectation that it's going to be building stuff for us, and that might not be here, builder. Okay. So yeah, okay, so it's actually building it through Rust. I was wondering if we would need a server or something, because we don't have anything that's running the vanilla JS server effectively. So our run should have a let mute builder, commands, collect commands. We need to give it the hello world. And here we only want to export a non-release builds. That makes sense to me. And then we have and finally tell Tauri how to invoke them. And this is the big change. Invoke handler switches, because this generate handler ends up getting handled by the builder. So the builder is wired up to take the commands instead, and it's sort of like sits in between your commands and what eventually ends up getting passed to the invoke handler within Tauri. And it basically like takes that content and then generates a TypeScript file off of it, which will give you a TypeScript exporter, and we should get a client out of it too, I believe. Yeah, we should get a bindings. So this is going to go, we've copy and pasted, but this is going to go into source bindings.ts. So it'll show up, here. And then we do need to annotate our commands. And this is going to be the bit that's interesting. It is annotating this command. Okay. We'll see how it works with async. Part of this is I wanted to see how it would work with async. And we'll do some use statements. That should clear everything up, I think. Does not need to be mutable. We'll trust the compiler. Let's give it a go. And we do an npm run Tauri dev. This should, in running, generate a bindings.ts file for us. So we'll see it. Part of this is going to be how does it work with async commands, and maybe the features too. But also, I'm not certain how it's going to work with channels, but we will see. We will see. All right, so we got our bindings.ts, and here you can see it's firing off the Tauri invoke, and it does some imports for us. So rather than us here importing in Invoke, we will instead do an import window label. Commands. Whoop, doesn't it? Whoop. There we go. It nests it then, right? Yeah. Export commands. Okay. So we can say we're going to fire it off if there's a message and an input. I don't. Whoa. Oh, I had the last one selected. That's why I didn't. We want an arg input. And we're going to say, we're not actually processing a return. We're just going to fire off the invoke. And this, instead of being an invoke, now we get a command. And this should be typed. So we can say await commands dot window label. And that, you can see, takes an arg, string or null, and it returns a promise. So we can now say this value is what we're going to fire off. It is camel cased. So I think what we actually do instead is in here we make our value camel cased. And we say if this and commands that is going to be our command, and it is potentially string or undefined. So then we can say if command in commands and let's check undefined first. Okay, so if we have an input here, we have a command, and that command is in the list of commands, then do the command. So it will then be command. Now I'm curious if, yeah, so the typing is going to end up getting real weird here because the possibility of this is that it is, our command is string or undefined. So what we're going to do instead, we could get fancy with TypeScript, but I think that's just going to sort of muck up our the clarity that we're getting from Tauri Specta. So what we're instead going to do is say a window label. I'm actually going to go back to snake case so it matches in the Rust side of things. And what am I missing with my switch here? Switch. I feel like every time I use a JavaScript switch, I end up having to look it up. Switch expression case. That's what I'm forgetting. I don't know how I just can't keep it in my brain. All right, so we need to then, I guess we could just say a return, and we'll do a return and then await. In reality, we don't really need to do the return, but it feels cleaner to me because then we don't need to do the break. It will break for us. So now we have an arg input value. There we go. So that was a whole bunch of wiring to basically get Tauri Specta to wire this stuff up for us. So now, like, this switch statement will start to sort of like fill itself out based off of the commands that we end up putting in here, as long as we specifically annotate the command. And we have to pass it for it to work. But as long as we do both of those things, then it will it'll do its thing. So we've removed our console.log, so we shouldn't see anything here. And howdy chat. And we're not seeing anything here, which makes sense. But we are, thought we were logging out in the back, and print. So it should be firing off window label with arg option string and window. So it should be doing a print line. New dependencies optimized. That is definitely curious. We are passing in an arg. All right, let us split this up just in case. We'll have a window label version, and then we'll have an arg version. And now this should, if there's some like weird panic or error or something going on there, hopefully make that a little bit more obvious. And like the ordering of these is not, because it like goes through the macro command specta command arg window. Yeah, it's not quite clear if the order matters. All right, fire command. Fire command does not appear to be doing anything. We can also do a, after the switch finishes, we should be able to do a log. And we'll say ran command. Okay, so it is definitely not doing its thing. Let's take out the window. And let's see if that's what it is. So like, I don't know what the order of these is, and it, like, the compiler isn't helping me out. I think in part because it's a macro. So it isn't able to like figure that out. But I'm not seeing anything come through, which is certainly curious. It can also be our if statements here. We can say else console.warn no command ran. And let's log these out. Okay, no command ran. We get the placeholder value and the command. So no command ran window label. We are looking for command window label. So it should be going here. We should be getting because I changed the command signature. Okay, we're just going to take this check out. I don't think that's actually going to help us as far as clarity goes. And if it throws an error, it's not a big deal. Okay. Fired off. There we go. So we got an arg. We got an arg. Let us then bring this back in. And that will be a window and window. We get a Tauri rebuild. Cargo rebuild, I guess, of our Tauri project. And now we should be getting the arg and the window label through an async command with Tauri Specta. Hi. Sure. There we go. So now it's coming from window label main, and we're getting an arg. And why that is nice, the window label is nice. If you start to get into multi-window, that ends up being helpful because you know where your commands are coming from. So you can have one command or one window fire off a command. We can see which window label it was fired off from, and we could respond either to that same window or other windows. So like one use case for this would be you can have a main window be the thing that controls the other windows. So click a button in the main window and it closes all the other windows or closes one of the windows. So that can be helpful. And it doesn't seem to actually matter which order we do these in. Let's see, let's just double check that. Because I don't see anything that says an order, and I don't see any compiler error. It feels odd to me though, especially coming from more of a JavaScript line of thinking. But let's give it a shot. Arg, window label. Yeah, okay. Works fine. I'm not gonna bother bringing in the state, which is in one of the examples as well. But let us get into the channels now. What do we got? We've been going for about an hour. Yeah, let's get into the channels and see if we can get some channels working. Because these are all let's actually copy one. We'll copy one and then we'll come back to it. Because like raw future commands, that might be useful, but I don't know of a good use case for that offhand. This deals with errors. We saw the wild card. Command arguments wild. Which is in the same way kind of this. So if we don't actually specify an arg, it basically takes any payload, I guess. That's also sort of a, like, what's the use case for that? All right, so here we have a struct, and it is inline person. You can see there's this derive macro doing the deserialize, which is coming from Saturday. And effectively that means that we have a struct here or here. This is doing an inline person. So we're specifying a struct and then we're basically like adding in the args. Which it's accepting a string and a UAID. So like the type doesn't matter, but the like arguments, like argument names matter. And that's returning that inline person. If I'm going to do this, I'm probably going to do it this way. But this basically lets us specify a struct and give structure to the payload that we're accepting, which I think could be useful. Like that feels like a nice thing to demo. Because I suspect that's going to be a common, like a common use case. I'll put it in here and I will wire it up. I'm going to also call it async, even though it doesn't technically matter. And we've got to deserialize in here already, so we should be golden. Then we would need to put it into this. There we go. Okay. So we're gonna get a rebuild. Ooh, what is this? The trait bound is not satisfied. The following other types implement trait Specta type. Yeah, so that's why I wanted to bring that in. I wasn't sure how this would work with Specta. Okay, we're gonna take it out for the moment because I don't want to. I don't want to get sidetracked. I want to get into channels, but we have it saved for future us if we still have time. Now, channels. There's not like a top level docs for it. If you go to the calling Rust or calling front end, both of them have a channels section. So here we're calling the front end from Rust. So this feels a little bit odd. So it wires up a channel and then it's logging out on message. To kick it off, it fires off an invoke. So it's using the command, and then that command, it doesn't say it's async or anything. It just uses the channel. And then every time we get in, okay, so it's actually doing this. Okay, so it's downloading a schema, which is probably going to go real fast, but it's going to download it in chunks. And as it's downloading, it will like send events back. So we can actually copy this one, I think. Functionally though, how is it different from this? I don't think the example is going to be that different. If we look here, so this is doing load image. You can see here it is an async function. And this comes back to we're specifying an async function, or we are doing like Tauri command async. In either case, we are like opting into Rust handling it in an async manner. The difference is here we are specifying it as an async, and we get this reader. Where does that end up showing up in? Let's see, custom command. That doesn't. Let's see. So it's still doing a reader.send. Okay, so we're there's really not much as far as documentation goes here, and you can see that it actually points back to this one. So this download command takes an app. Oh, it's got an app handle. Ooh. So that's nice. I wish there was a way to see like I'm pretty sure there's a way to like figure out what like args are part of this. But I don't know offhand. But we have a app, we have a URL. So that's going to be the payload. And then we have the channel. So this on event is basically the front end subscribing to these events. And we wanted to look at the channel here. That was definitely something that we said, let's look at. We have a download event. Saturday, you can see the Saturday rename. Let us grab these bits. I think this is something that we can try out wholesale. So now we have a command. It doesn't specifically say async. We want Specta on there. Well, let's see how Specta deals with this slightly different version of. And then in here we have a type, and then we do the like on event and invoke. And this is firing off that invoke directly. So we'll change that a little bit when we get here into the front end. We specify a type, that's fine. We're doing the new channel. We need to make sure it's imported. I shouldn't need an invoke. I do need the channel because we're establishing a new channel and then we're logging into that on okay, so every time the channel gets a message, it has like event listener stuff. And then here, we don't want to do an invoke directly. Let us wire that instead into this. So now we should have, as we've been saving, could not compile due to two previous errors. Channel's not found in the scope. That makes sense. We need this. IPC channel. And then we'll add an app handle in here too. Ooh, there we go. So there's a bunch of warnings about unused things, but that's not a big deal. Some of this is just to, like, if you're doing something like this, having that enum available is nice. So like, even though it's not really used downstream of this at all, and it's just specified here, like that's fine. Function download is never used. Command async specta. Command specta. We do need to add it here. So now this is going to run through Specta and then eventually the handler. Now the question is it going to handle it? Trait bound download event is not satisfied. Yep. Function Specta function. So this is expecting a bunch of args, and the trait Specta is not implemented for download event. What is download event? And actually, this is the same error that we had here too. So let's double check the docs. There might be additional steps we need to do if they're doing a struct. Similar to serialize, you must put specta type derive macro on your own types. Got it. So here we have specta type. Okay. What are we doing to use? We use Tauri Specta. Here, and there's this. So we want to do a oh, we don't have a specta at all. Okay, so we'll say a use specta. And I guess I don't actually need to do that if I'm just doing this directly. I like specifying it like this. So I'm not going to do a derive type. I want to do a derive specta type. Because I think that it's going to make it a little bit clearer. So here, instead, we're going to do this, and instead of doing Specta, we want to do that. I think that will work. I'm going to dump it here as well, because that I think is the reason that one wasn't working. Okay, let's see how this goes. And if you haven't used Tauri Specta before, it works both with commands and events, which is pretty nifty. Failed to export TypeScript bindings. Ooh. Big int forbidden. Okay. So what should we use instead? Does it actually say? Download event, download ID, usize. So we can't do the usize because that is a forbidden value. So what if we do just like a U32 maybe? I don't remember offhand like what JavaScript allows relative to what we can do with Rust. We could look it up, but you know, it's easier just to try it. Hey Dengel, yeah. Honestly, like I had kind of just not wanted to deal with another thing for a while. And I think actually when Attila was on, we pulled in Tauri Specta, and I had mentioned on that stream, I'm like, honestly, if I'm doing anything with like any more than one command, I'm gonna probably want to bring in Tauri Specta because it's nice. All right, so we get this. It is compiling. We are doing this, and now let's add it as an option. So what we're doing, context, if you're catching up here, Dengel, I wasn't sure how much Tauri Specta could do and like how much it could do as far as like the advanced type of stuff. And so part of this is just I chucked it in there to see how far we could take it and at what point it would start breaking. So sort of like no expectations. We pulled into the async command, and then we just started getting into the channels. So we pulled into the download example. And then I also grabbed this too. We started from last week. We were going through the commands example and just sort of like touching into the async stuff. And then we left channels for today. So this is like, you know, I guess in some ways I had in my mind Tauri Specta was an advanced thing, but honestly, it's so helpful. It's almost, it doesn't take too much extra to wire it up. And yeah, I've got a similar feeling. The work that was Oscar and Holtz was working on it. Oscar probably just do this. Oscar and yeah, Brendan. Yeah, prime work. Appreciate both of them. Yeah, like in my mind, I'm like, I know what their avatar looks like, and like I could picture it was like Brendanovich or something like that. Is that what the? Yeah, like I could picture this, but I'm like I can't remember what their actual name is. Anyways. Okay, so we've got download. We have it added to the commands list. We need front end now. Front end. We are going to do an options and guess I called it download. We could probably change that. We'll say like download chunked JSON. So, and then the pretty print, download chunked JSON file. The arg doesn't really matter in this, but I'm not gonna bother too much with caring specifically about that. And I'm gonna switch this to download chunked JSON, of which we also need to update the same in a command list. We should get a bindings. You can see here that it is not quite run yet because it hasn't finished. And then here we can add it case this. So now we can do a return await commands. Whoop. What are we doing here? Commands dot download chunk JSON. It does say it takes a, I guess it does take an arg. And there's the 2 bits here. We probably want to keep this in global space because we can just keep piping events into it. And I'm actually a little curious like how it's going to work as we like press the button multiple times. And what does this expect? It expects them as separate args. So we have a URL. And here you can kind of see the difference. Like here's the payload here. This is going to be our payload now. And we can get a little bit fancier with that if we do a struct, I believe. But that is a thing we can try afterwards. Okay. So now we should have, double check it's not rebuilding. Nope, it's good to go. Are we logging anything out? Yes, we are. Let's open this up. Do this, this, and this. So now if we fire off a command, download chunked JSON file. We don't have any events in the console or in the terminal, excuse me, because we're not logging anything out. In our window label, we were. Here we're not. Every time we get a new chunk, so on event, download chunk JSON. So this on event comes from the channel. Okay. So on event, it sends the URL, download ID, and the content length. Oh, I see. This is like the initial event, or initial payload is probably the better thing to say. And then afterwards, for every chunk length from there on out, it basically continues to send events. And then after that's all done, then we send the finish. This is doing a download chunked JSON, and it's in the commands. Is there any, what's actually fetching that content? So here we're doing a download chunk JSON. We have this value, or we have this URL rather. That URL ends up showing up here. On event, channel download event, on message, phantom data, tsend. Okay. Oh, it's faking it, isn't it? I was like, how is it down? Because like here, if we just do like any random thing, just do a refresh just in case. Yeah, we get the same thing. So it is basically like faking the request. I'm going to put a note for future me here. And this is maybe something we should dump into that example too. But as an example, we hard code what a sample buffer might look like. I guess it's not it's not a buffer. We're in Rust land at this point, so that would be, I guess, is this still considered a buffer? I'm not 100% certain. U32, U32s. It's just an array of U32s, right? I mean, you know, like in JavaScript land, that's a buffer. So what if we do it multiple times? Is there, and then I guess we are getting logs. Let's on message. So every time there's something happened, we do a new message. So there's messages here. We're sending a started, a progress, and a finished. Excuse me. Which is part of the enum. We have a started, a progress, and a finished. So we should also be getting, in each one of these, we get a URL, a download ID, a content length, and then another ID. What's the download ID? Oh, 1. Okay. And then we're just hard coding content length. Okay. Oh, no, we're not. Content length for the initial, and then we're putting it in here. So what we can do here is say, when we get a message, download event, what does this look like? So we get data. So what we can say is we can actually say data, right? Message, wait, no, event and data. I'm actually not sure what comes through here. Download event. So message dot data. Okay. And actually after this, I want to, what time we got? We might want to look at so like we have channels. If channels end up not meeting your needs because you need a little bit more control over either side of the equation, what does that look like? Like we've got the streaming example. The commands is, so this is firing off events. So in this case, we are controlling it from Rust. The JavaScript side or the web view is, it's basically just as it gets to the events, it handles them in order effectively, I'm presuming. So the control flow happens from Rust. Is it possible to do that on the other side? Like we've got this on event in the channel. So I think that would probably be my curiosity is, like, is this just an event emitter? We'll have to look into that. And like what that channel actually is. But depending on how much control you have over that, like at what point do you start needing to look at you know, like that streaming example that we have, where you have your own custom, what's the word I'm looking for? Custom. Let's look it up. Where we have, please hold, URI scheme, your own custom URI scheme. There we go. Okay, so did we do the things? We got to talking, and I don't know that I did the things. We're sending. We should be. Yeah, we're logging now. Okay. So let's fire off a command, download chunk JSON file, and we get our chunk lengths. So if we actually fire it twice, or even, oh, it only worked once. And that's the bit that I was curious about, was like, what's the, I'm guessing that's part of this channel. So like, is this channel closed? Like, is there a reason that this is not emitting events anymore? Hey, Chris, good to see you. I think that's a good segue into let's check out the channel, because I mean we could in theory fix this by like every time there's a command, we could set up a new one of these, and then like in theory I think it would work. I guess it's going to depend on how the mutation happens, but if we click it, no, okay, so it's not working at all now. Yeah, let's look what that's doing under the hood, because it is. It's doing something, and I'm wondering how it's like closing that out and handling that. So I think the thing that like the gap that would maybe be nice to fill, at least in our examples, would be I'll end up pushing this up. I don't know if it, at least at the moment, makes sense to see to push Tauri Specta into one of the examples. But I feel like there's a gap between the commands example and the streaming example. Like, at what point would you need to jump into a custom URI scheme? So, like, if we could answer that in the example, I think that probably would be of value. There's been a few people that have asked, which is part of what actually brought this up. Okay, so we're getting that now. But it only fires the one time. So let's look at the channel and let's see what it's doing. This is part of core, I believe, right? Oh, wrong file. API core. So we can go packages, API, core, and we have a channel. So a channel is a class with a constructor. And we've got an onMessage, getter setter, serialized IPC function, plugin listener, add plugin listener, adds a listener to a plugin event. Returns the listener object to stem, adds a listener to a plugin event. So I'm guessing that's just, you can make a channel for a plugin. So is this sort of like global-ish state? This package is accessible. Given a type like this. Okay, so it explains how to do the, like we were looking at this before. If we did like an enum or gotten fancy with like our serialization here. Transforms a callback function to a string identifier that can be passed to the backend. I don't know the use of that at the moment. We will come back to that though. So this is doing a got a big function in our constructor. Pending messages, next message ID. And it takes a, well, it's setting an ID based off of the transform callback. So that's got a, how are we using it? And I guess, does it take any, no, here, this is what we want. So we're giving it a type. I don't think it takes any args, right? No. I guess I could, yeah, constructor. We've got our invoke, convert, close is Tauri. So we sort of brought up this question last week. Is a channel in the same vein of something like the channels in Go? It feels like it's a sort of like a naive implementation of it. Like a real, I mean, maybe I guess no is probably the better answer. It is basically just looping through all of the, yeah. If we do not have the next message, let's, oh, wait. We do not have the next message, let's, and then I paused and said, wait, because what is it actually doing? So the transform callback, it's using the transform callback. And there's a, okay, so we're doing once as false. So it'll be false. So transform callback only, or can happen more than once. And the ID is used as a mechanism to preserve message order. So if a message will have an ID, and on message handler, so we have a handler for the on message, which is this. So we set it originally, and then we get it when we call, and then there's also to JSON. So why isn't it firing off more than once? Next message ID is 0. This is an empty on message, I'm guessing, so as to give it a, like, make it optional effectively. Used by the PC serializer. Okay. Pending messages is a record. The ID is used as a mechanism to preserve message order. So it is, if pending messages is greater than 0, then loop. And we, if after we're done with that, then we set the next message ID. So how does it come in with, let's see. Our chunked, yeah. So we're giving it a channel, which is, or it expects a channel. And here we're sending events. Data unwrap. On event is a channel. So Tauri IPC channel. So we can maybe check out the Tauri IPC channel, but it's basically just sending events. And then this is in some ways, kind of like like functionally, what is the difference between this and like a generic event emitter? Move the counter ID to the next message in the queue. So there's a to JSON. Let's do a on message. Whoa, here we go. Let's do return serialize. I don't think if we do on event dot to JSON. So every time we get an event, let's log out the JSON that we have, and we can maybe see a little bit more. All right. So it's just doing the serialize. It's serializing that old function. What is this? Serialize to IPC function. Channel this.id. So it's giving the ID for this. So this transform callback ends up returning an ID, and that is like the thing that just starts handling stuff. So we don't really have any internal view into that other than just knowing it's a channel with an ID, which I think is in part because we also have a plugin listener, so that needs to have a separate channel ID. All right, so we have a got download progress channel ID. We really don't have any. We can't inspect this too directly. We might need to jump into the node modules to like get at it more directly and kind of inspect it. So it's got an array of pending message IDs. We do not have the next message, so let's wait. Doesn't actually, so it's looping through pending messages. So if there's multiple entries in pending message IDs, then it loops through it. It deletes them. So after it's finished the message, it deletes the entry. If next message ID is there anything that's actually changing next message ID? Okay, here. Okay, so interesting. Okay, so if we go like this, let's see if I can confirm suspicions. I don't know if that's going to still continue logging. I'm going to take off that because it's not actually helpful at all. And then let's do this and then this. Fire command. So we get those events, and if we do it again, yeah. So it's recreating it every time. So I think what's happening is, I don't know if this is intended or not. It says break. We do not have the next message, let's wait. But in reality, there's nothing that I can wait for unless you are, it's going to process all of those messages basically in one stream. When it's first constructed, it has a message ID of 0, and then it loops through all of them. So by the time it's done, it might have a next message ID of like 6. When we receive the next event, that's going to have a message ID of 0, I'm guessing. So that it doesn't have a way to continue to process messages. So like once it processes one stream of events or messages, it's done. So you need to, if you're doing something like this, you need to recreate the channel every time and then handle the event every time, which is like even in vanilla JS, that's which is you end up having to use like event emitters and event handlers a little bit more in vanilla JS. Even with that, having to recreate it every time is a little bit painful. But also, this isn't terribly easy to resolve. We could, in theory, do something a little bit more full-featured. That's probably not going to be a today thing. But like the channel could be more full-featured as long as it still has the same, like I'd presume you'd be able to swap in a different channel handler or a different channel to handle these cases, as long as the type signature is the same. And what is enforcing that? So I guess in this case, it's technically Specta enforcing it here. So as long as this has in channel here, so we would be able to look at what's our Tauri channel look like. This. So as long as it has the same type signature, it would technically work. Real quick. JS event. Emitter? Like, it's not clear to me what, like how this ends up being processed. So I think to do, yeah. So like Node.js has an event emitter, and like in the front end you do like the add event listener, which is effectively what we're doing here. Let's do creating and triggering events. So like functionally, how is this different? I haven't actually used this interface, like the low level stuff, too much. Target source. Yeah, creates an event object returning it to the caller. So like, I think you could in theory also just do a generic event emitter. Technically this is enforcing it, but like you could get set I mean, I don't know that it's doing too much other than I guess it depends what it's doing with this transform callback, because this is the thing that ends up handling and then eventually calling the on message. So I'm not quite clear if this is actually happening. Like, there's some level of like thing invoking other thing. So that's the bit that we need to understand, or at least I need to understand that better. And that is coming. So we're doing export transform callback, and that's coming from Tauri internals. Invoke, check permission. Yeah. So let's see if we can track down the internals. I don't recall where that's going to be offhand. It's not going to be in the API. Tauri, I think that's in the main. I think that's in here somewhere. So send IPC message. So what Tauri is doing, or part of what it's doing, is that when you load up a new web view, it's injecting these scripts like into that web view, so that basically like attaching it to the window object. If you're familiar with that paradigm from back in the day. And then it adds like event listeners to do some things. Part of which is like depending on the way you're handling things, or if you've defined the configuration value for with global. Excuse me. If you want the globals in there, then it injects stuff to enable that. All right. Okay. Sorry about that. I think it was like, I feel like I'm kind of losing my voice here. All right. So here's the Tauri internals transform callback. It is doing a define property window prop. So from the identifier, so it makes a UID. So it's really not doing anything. So every time the channel is called, we don't have it anymore. Every time that's called, it is. I guess let's open it up. We need to be able to look at this. Packages, API, source, core. So we have a channel. We do the constructor. It has basically set up an ID, and this ends up being like the handler. So when this is the function that ends up being fired when we like this is basically the like on event handler for the channel, and based off of this ID and the fact that it's serialized. Okay, I think I'm starting to piece this together in my head. We need to basically Rust is firing off an event and sending it to the web view, and the web view needs to know, like the code in the web view needs to know how to take that event and then basically fire off the right thing. So this serialization is defining an ID, and that's going to match up with that command on the back end. So that is the connecting point. And what it ends up basically doing is that transform callback. We get we're effectively firing off a callback every time we get an event from the back end, and that callback is basically firing off the handler for that specific ID, which ends up being this. So if we took something like this, completely irrespective of like this whole looping mechanism, we could in theory just every time we get an event, log it out. So this is going to call, so every time we call transform callback, it's going to fire this off. Let's try it real quick. This is going to get potentially a little ugly. Let's just dump it right at the end. And we need serialized IPC function key. And then we need transform callback. Transform callback is a function that is exported. So we can then do this. So on event is coming from, why is that argument of type is not assignable to parameter. Yeah, so this is like, we could in theory do whatever we want as long as it just ignores it. As long as it just ignores it and it knows how to fire off the actual command. So here this will give us the callback, and let us do a console.log and a message and an ID, and we'll see. So this constructor is going to happen once, and this is going to happen once. This event or this callback handler is not going to be, I think this is going to be fired off multiple times. And I think part of the reason is once they don't have any more messages, it keeps advancing. So if it is the next ID, otherwise it says this, and then like in theory we could just say this. I think that would be enough. But let's test it and make sure that it is working as expected. So we're going to fire off a command. We got the message IDs. So you can see here we got a message ID 0, 2, 1. Oh, and oh, that logging order is a little bit weird. I don't think it means that they're coming in odd order, but that is curious. So now if we do it again, oh, we are still also recreating it every time. So right now we are we're creating that channel every time that we click the button. Yeah, I don't care about that. So now typey, download chunk value. We're not getting any logs. Class channel used before. I mean, in theory, I think that's fine. I guess I will move it just in case. It is a top level thing now though, so I think that is like part of the issue. So when it was inside of a function, it wasn't actually like we're basically invoking it too early by moving it outside. When it was nested with inside of the function, we weren't actually invoking that function until we had defined it. If you had a bundler, it probably would not have been an issue because it does it hoists stuff for you. There we go. So we have a ID 1, 2, 3, 4, 5, 6. That logging order is definitely interesting. Actually, we can double check too. It should be 15, 150, 35, 500, 300. So like these events come in as expected. Where am I logging? So I'm logging every time I get an on message, I'm logging. And okay, so every time this is called. So that's called on every message received. Yeah, so the receipt of and it handling these is it's a little bit of a you really have to think about it. Because it'll do so pending messages. So every time this is called, if we don't have that, then it is adding it to the pending messages. So if there is no pending messages and it's called, so like how do you know that you've processed all the pending messages to where you can reset the ID? It is like I see why it is the way it is. But I would definitely be curious if we could make this better. Hey Nicola, good to see you. Appreciate if you use a word other than guys, because that is sort of gender specific. No worries. For next time. Y'all is a good one, especially if you're from Texas. Not that I am, but every time I visit Texas, I feel like I get into using y'all or folks, or just omit the word "what's up." Okay. Anyways, channel. We can't do this because we're calling every time we get in. Every time we receive a new message. So like this is doing two things for us. It is firing off and handling any pending messages. So anytime there's more pending messages, then it just starts going. And part of this is built on the fact that we have a start event and a finish event. So we know when it started, we start priming that pending messages. And then when it's finished, we know, well, it's done. So in theory, actually, we should be able to say when we receive the, if this, what does our message look like? Messages event progress. We could, so when we get our finished event, that is also a message. We can say this pending message is message. That's fine. But after we process the last one, this doesn't do anything special as far as processing goes. It is saying save the message, delete it, pass it to the handler. Then he go to the next one. We don't actually need to go to the next ID if message dot event equals finished. What don't you like? Does not property event message. So we're logging a message. So if message.event is it not on everyone? I don't know why TypeScript is complaining there, but T unknown. Okay, fair. In this specific case, so like part of this is channel is generic. It's a generic handler. It has no way to know like when you're starting or finishing. In this case, we happen to be passing in an event that is then defining it. And here, like channel T unknown. So we can't say that it's going to have an event property because in our case, it happens to. So we could go like this and it would work. That is not applicable to every case though. So we can say here T equals download event. So if they don't specify it, yeah, it does not exist on type T. I mean, we could just go like this. And we can just say if you happen to do pass an event, you know, just so happen to. That would reset it. Okay, so now refresh this, that. There we go. So now we get the message processing, but it's not actually logging out the on message anymore. So because it is it's basically like stopped looping. So this stop pending messages. So like here you can see we get a new one. So we start getting progress and then finished. But now this is off. Oh, weird. So they say next. Okay, next message ID is that is 0, and they have a constructor which is doing transform callback that gives us this. And we say here basically we're going to process and say if it's nested. Wait, what? So where's our next? Our next message ID is 0, and it's saying ID +1. Got it. So actually, in reality, this should be ID, because that'll basically make this true. In which case, it'll continue to process. Like I see what they're doing. I understand the intent. Yeah, there's still something a little bit off with. I don't know that it's actually. Here, let's log this out. We'll say next. So next is 7. So 0, 1, 2, 3, 4, 5, 6. Next is 7. So we never actually get to the point where we're checking this. So if we do, oh, it overwrites it. That's a bit of an oversight. So we'll say we're going to change this to pending message. And that should work then. We were clobbering. Detect object injection. So it's still next to 7 though. console.log message. So if we do that again, our last message here is get download event. Here, progress data. Ooh, this is getting it's getting a little bit much. So here we're logging out message. We'll call this loop message, just to help differentiate a little bit. Now loop message here. So we get a progress and we get a progress. So we're getting, this is what's kind of interesting, is we only get loop message twice. And okay, this is actually clearing it up a little bit. We are, because as we're processing and writing out events, it continues to receive events in the background, which is then effectively like mutating these, I guess. Yeah. So, and that's why it seems like that we're like getting them out of order. So we get an event, so it starts, and we receive the start event, and then we get progress events. And we've been looping through and we start logging those out. And we get another progress. And then we get another progress. And then we are finishing back through the loop. So we get here. And then it eventually hits the 6th message, which is finished. And we have logged that out. But at this point, we are next ID. Okay, so it's doing appending IDs. Okay, so then they break. So our loop message here is a message. Loop message is progress, another progress. But we only get 2 loop messages, which feels weird. There's something else that we're missing in here. All right, well, I guess I'm not too I get the intent here. We could figure out and get it working to where we can click this and fire it off multiple times, but also like that starts to get, it almost overloads the intent of this in some ways. I think the thing to remember is that we have a callback, which is a message and an ID. The ID is the it's the handler, like the transform callback ends up basically generating an ID. So for this specific channel, we have an ID. Now, every time we fire off a message to that handler, like or to this callback, every time we fire off a message to the handler, which eventually hits this callback, there we go, it's doing this. And we are logging out every time we receive that message. So we're getting a started and then we're getting progress events. So every time we do a send, we get a message here. And then everything in here is just trying to attempt to handle that. So there's no, like it's not really a Go channels or, structured concurrency or whatever you have, whatever event handler type situation. It's basically just like getting IDs and then handling them. In which case, I feel like it would be kind of interesting to see what it looks like to do a more advanced version of this. Because all we really need is a way to send events and then handle it on the front end. So I think part of what we have here is that we can send events at any interval we want in the backend. So in Rust, we can send the events at whatever interval we want. We can send a whole bunch and then stop, and then send a whole bunch and then stop. This channel implementation is not going to handle, like it'll handle one stream and that's it, and then you have to like reconstruct it. So you're gonna like basically be reconstructing these multiple times depending on what you're doing. So I think to answer the question, yeah, well, let's take a look at that real quick, and then we'll sort of do a quick review. What am I looking at? Examples. I want to look at the streaming example, because if we're talking about like what's the difference and to what point do you need to like at some point it would potentially make sense to switch from command and channels to a custom URI scheme. What would prompt that? If we want to look to answer that question, we have here a get stream response. So there's a custom URI scheme. It is responding. It is calling the get stream response. So we're going through here. And what this is doing, it is, this one is actually doing a call. So it's doing a file system thing. It does an HTTP response, and then it downloads like a video, and we get it in ranges. So ranges is like an array of bytes representing that file. Now, in here, we just like this beginning part is doing a bunch of work. So all of this is basically doing a bunch of work. And then after it has completed, so there's no, I guess something to be said about this. There's no, like it's not an async function. We are, we're returning a result. It's just a normal function. So it does a whole bunch of work synchronously, and then after that's done, it loops through and is doing is returning a response. So in the front end of this example, if we put, there we go. If we put this on the side, and we look at index.html, this is doing a video thing. And from what I know of the video API, like it's a HTML element video, it's basically like a streaming response. And every time it gets new chunks, it will, it fills the buffer within the video file, or like within the video player. So what they're doing here is, if there's only one range, then just do the thing. Otherwise, we get in, we do a ranges.editor filter map, and then we collect. So we get a vec of these, whatever's in here, what like a vec of numbers, basically content. Decode UTF to string. Yeah, so it's a vec of content U8s. Here we go. Vec of U8s. Vec for the JavaScript folks out there, basically an array. So like an array of like a buffer effectively. Now here, what we're doing is we're defining these. We basically do like a multi-format or multi-part byte range header, and then we write starts and ends with bytes. And then at the end of it, we basically, like, in the header, we've said, hey, that here's the start and end of this this chunk, and then we send the whole thing across. And then the response that it gets is basically a way to stream that that buffered, or like buffer that and stream that response. HTTP response.body. So the body ends up being the buffer, which is the buffer includes the vec. So it includes all the ranges, of which it is content type range. Yeah, so like it has everything in there. And it ends up being a streaming response. So it responds once, but it is like it's a really big response to where the front end can process it as it is receiving it. So it's not it's not in a place where Rust can, at whatever interval they want, fire off content. It is in a place where, and some of this is like HTTP spec, like streaming video spec type stuff, I believe. It's one single response, and within that response, it has these headers that tell it how to like process these chunks. Like every time you have finished or you've gotten to this byte, then this is a chunk. Like you finished a chunk, you can continue into the next chunk. So, well, this is in some ways async. So if somebody would say, I want to be able to handle async from the front end, it is like every command is async. It's the invoke, you have to, it returns a promise. So you have to await or handle the promise. In the Rust side of things, it's either synchronous or async. And then if you do async, you could also do the futures directly. In this case, it's effectively synchronous in the Rust side of things, but the response is of such that it's a single response to where the front end can process it in chunks. So it's like the streaming example is not technically async in any way. Not in the way that I think most folks would think when they say, I want to handle asynchronicity. And I think that's where the channels starts to come into play. If we look back here, I guess we could look at our code too. We are doing at whatever interval we want. Like we can do a bunch of synchronous work, or I mean, it is. What if we do async here? Is that gonna be fine? Is it gonna be fine with that? Then I think, this needs to be an option? Let's just try it. Yeah, so it's all still working. So we can make, with the channels, we can make this interaction be asynchronous from both sides. The front end can handle, or it has to handle it async regardless. The Rust side of things can handle asynchronicity, or either sync or async, however you would want to handle it. In which case you can, whenever work is done, send events. So could this be considered a streamable set of events? Yes, I think is the answer. Considered a streamable set of events. Maybe to restate that, we are firing off, we've defined an on-channel, so we have like a handler for it. When we call on event.send, we are firing off like, you can think of it like firing off an event to this handler. And that handler, every time we fire off .send, we are receiving, or what we're in our channel executing this callback. So this, if you're just showing up here, Bogdan, we pulled in the class channel, which is typically imported from Tauri API core, just so we could play around with it a little bit. And this, in the constructor, we define this.id, and like, I don't think it would have to be exactly like this to get it to work, but effectively it is with this type signature executing this callback every time you call a .send on the front end. So every time this call, or every time that callback is run, you could handle it in any way you want in the front end. So like this could effectively work like an event emitter. So this could fire off events. This could call whatever. I mean, like anything you can do with the function, it can do that every time you call a .send. So depending on what your command needs to do relative to how you want to handle it on the front end, you could do, like, it might be interesting. Maybe this is a good way to sort of cap this. The channel at the moment appears to be sort of a what's the right word? A simple message handler. In which case, if you want to do anything more, it might be interesting to have a like a constructor, like a class constructor or template, or I'm not quite sure what it looks like, but some way to like more easily spin up a custom version of the channel so as to handle it in any way you want. So if this is calling the callback on every .send, like I mean, streamable set of events, like it's in some ways effectively a whole bunch of events, and that event is immediately calling this function. So that's why I don't think it's a clear answer, Bogdan, because it's not really a streamable set of events, but like you can make it that. Every time you do .send in Rust, this function gets called. That's the like most straightforward way I think we can put it. And then what you do with that function ends up determining like what it looks like. So if we fire off an event, like it could be a purely like new event from, like MDM. It's like sending mouse events to, yeah, exactly. Yeah. So like, all of the, like you could do this. So you could do, a new event and dispatch event. So like literally every time we call that, you could just dispatch an event. And then at that point, it's just a generic event listener. I'm sure there's something I'm missing. I'm not certain why we didn't do it that way. Like this feels like it could just have been in some ways like an event emitter effectively. Like there's not really an event. Like you can call dispatch event, but there's not like a not equivalent to like Node. Like Node has an event emitter, right? I guess that it looks pretty much the same. Yeah. No event emitter. Okay, well, and there's an emit and on. So I guess it looks, the function signature is pretty similar. But yeah, like in theory, this could be as simple as an event emitter. So I imagine there's some reasoning for why it was done this way. Some message handler, like it might be a security thing. Not certain. Like there is some level of like we're checking to make sure that the IDs match up, so we're not just emitting everything without any like separation between channels. But you could do that with events too. So I don't know. I think what I take out of this though is that we can make channel a little bit more generic in a way where we basically like pass a handler, and then the handler could be as simple as an event emitter. Then everywhere else in your code, you just listen for the events, or it could be as complex as something equivalent to like Go channels or structured concurrency, etc. Like you could do the whole shebang and handle it however you want. But I think that gives you a lot of flexibility, because then there's you can do any of the synchronous or asynchronous work from Rust, call.send, the on event.send, and you'll just get it however you've defined it on the front end. And I guess that coming back around, it sort of answers the question here. Why would we, or when would we want to at some jump into doing a custom URI scheme? And I think the answer is that when we have a very specific way we need to respond that we can encapsulate for a specific use case. So like this isn't inherently a command. It's just a way for us to return a response from Rust that very similarly or in some ways mimics how a browser would fetch and grab content from a server. So the actual like HTTP response is the thing we want to customize and respond with. So the video player is the thing doing the actual like request, and then the request gets handled by Rust. So we need to match that very specific like spect response, and that's when it makes sense to do an asynchronous URI scheme protocol. In the case of channels, all we want to do is be able to, in a more custom way, maybe not even more custom way, but have more control over when or how those events are sent, rather than just immediately responding or responding through an async function. So I think that's good. I think that's a good place to sort of like wrap it up here. We'll go back and give a quick demo on the two things that we've played around with, but the question is, if you want to do some real advanced handling of the messages back and forth, and I mean, there is still that serialization. So I'm not sure like performance wise like how that would all work. It might be dependent on what you're doing, and that also might dictate some of when it would make sense to do this custom URI protocol. because you could avoid the serialization. That I guess that's probably the two things. Okay, so you would want to potentially choose the register asynchronous URI scheme protocol if the response that you're sending back to the front end has to meet a specific, like a spec standard or a specific format. So in this case, it's using the video element to make the actual request, so it's expecting it back in a specific format. And in which case, using this protocol, we can mimic what a browser might see from a like a backend video service. That and shoot, now I lost the other piece. What did I just say? Oh my goodness! So it's that, and then the other thing I just said. Clearly we're hitting the end of our stream here. My brain is starting to fall off the rocker. Serialize. Goodness gracious. Well, rewind. You can listen to what I said before, and I'm gonna go back and remind myself because oh my goodness. So like those are the two reasons I think to use the custom URI scheme. And if you don't meet that criteria, if you don't have a situation where one of those two things makes sense, you're probably going to be better served using the channels if you need to do more custom work with the if you need to do more custom work with if you need to do more custom work with your commands or your communication between the web view and the REST side of things, you can use a command and you can shift into async commands, and eventually you can shift into using the channels API. And specifically in the REST side of things, you're looking at the on event, which is, in this case, we have a download event. We've specified it here, and that is a Tauri IPC channel here. Yep. So we've specified the channel with the invoke response body. So that would be the reason. If you want to do more custom stuff, this. Okay. Let's do this real quick. We'll just show the couple things that we got working here, and then we're gonna call it a day because I need to get some other work done, and clearly I am both. It feels like I'm losing my voice, and also my brain is starting to lose track of itself. So we've got a little ish form in our web view. This has two options. We have an arg with window label and a download chunk JSON file. Those are effectively just executing some commands. We have these commands wired up through Tauri Specta. Tauri Specta helps us define a command in the Rust side of things. Download chunk JSON, window label, and then we give it the macro, and it effectively handles all the TypeScript stuff for us. It generates this bindings.ts. So we get a nice little command that we can use that's fully typed. And from there, we are then firing off. In this case, we're firing off the window label, and the window label will log out in our terminal those two values. So this is a async command. And then the other command that we got working was the download chunked JSON file. This is ripped pretty much exactly from the example in the channels documentation. So if you look at Tauri app and calling the front end from Rust, we have a section on channels. Channels allow you to have more control over when we're sending events to the front end to process. And then on the front end, we use the channel API from core, imported from core, and that accepts events. We're essentially, every time we call .send, we are executing a callback in the channel class constructor. And that then will in turn calls the onMessage handler, which in this case is logging it out. So the bit that we customized with channel, we pulled it in. We're still defining it in this way. And where is it? Minimized. We were playing around with this constructor. So this constructor defines a this.id, and it's using the ID and this serialization function to basically do the wiring between the Rust side of things and the JavaScript side of things, and know which callback to actually call. So once you've defined this ID, you give it a callback function. This transform callback is the thing that handles the ID creation and that wiring. So every time we call in the Rust side of things in onEvent.send, we are triggering this callback. And in this case, the API from imported from Tauri, that channel basically does a message log, and it fires off and loops through the messages that it receives, and then passes it off to the handler that we've defined, which in this case is the same as in the example. So I think potentially like future work, or at least something that I would be personally interested in getting into, would be what would it look like if we had a little bit more customization around the channel API, and or like the default could be this, but what if we pass in our own custom like handler effectively? So I think the thing that I'm going to do is I'm going to check in and see if there was a security reason or something for this specific API. But if we have more control over this, I think we can do some pretty interesting things. Like we could do full on like Go channels on the front end, or other equivalents, and the backend can do whatever work it needs, send it along whenever it's done, and we can handle it in the front end and at any like level of complexity effectively. And obviously this is going to be like if you're just doing a fetch request, or if you're expecting the information back like you would a fetch request in the web view, this probably isn't going to work. You're probably going to be just wanting to return from a command. But there are going to be situations where having the ability to handle it in any way you want in the backend in Rust, and any way in the web view, it's pretty neat. Okay, my brain needs a break. Next week, I think we might get into some mobile. I haven't actually scheduled it yet. I was going to schedule it before the stream today, but click the subscribe button so when that notification goes out, you can stop by next week. But I should have a good chunk of time that we'll see what mobile. I'm tempted to say let's try Mac and iOS mobile development, because I really haven't done it. I've done a little bit of Android before it hit stable. It feels like a good time to do that. But yeah, press the buttons. I'll see you next week. Have a great rest of your week. Happy Tuesday. And I'll see you next time. Bye.